Okay. Now I'm 100% present. I feel relieved that the audio issues are resolved. And we can now talk Unikernels. So Adam, this piece, I wrote this piece 7 years ago, and you read it at the time. You read it when it came out.
I did read it at the time. I'm a big fan of yours. Many time caller, big time fan. Yeah, no, I read it at the time. And as I was saying, I wasn't kind of living in the same world, so I don't know that I sort of knew all of the vitriol around and excitement around Unikernels.
The inside baseball of Unikernels.
That's right.
So this piece is a very specific reaction, actually. So the previous day, Docker had announced their acquisition of Unikernel systems. And Unikernels went from something that was, I think, an interesting and important experiment to all of a sudden being anointed by Docker as the future at a time that I think is like pretty close to peak Docker Inc. Like, when is peak Docker Inc? When does Docker have its maximal influence? I think it's within this time period. This is January of 2016. And I think that this is close to there because, I mean, Kubernetes begins to really take a lot of the momentum starting in the next 2 years.
No, I think that's right. I think that is sort of the 2015, 2016 peak of the hype cycle. I remember coming to you as I tried to understand this environment saying, why does X plus Y make any sense? Like, I see all this marketing around it. You said, don't worry, it doesn't make any sense. We're at peak containers. Nobody knows what they're talking about.
Nobody knows what they're talking about. Everyone knows that the room is very enthusiastic and no one knows why. And so everyone's just like, well, I'm just going to make up my stuff then. As long as everyone's just making it up, I'm just going to make up some stuff too.
Why not?
And leading to the chaos. Yeah, and I feel, God, maybe this was peak Docker Inc. Maybe Docker Inc. peaked at the moment they bought Unikernel systems. And this is the monkey's paw. Maybe this is what brought him down. So had you heard of Unikernels before? I mean, so you are blissfully...
So rolling it back, I'd sort of heard about it, but it is, at the time, I mean, I'm embarrassed to say, like, I was dealing with like versions of Oracle that were EOL'd before a bunch of the folks on the engineering team I was running were born. So I was dealing with a very backward-looking kind of technology space. So none of our customers were pestering us about Unikernels at the time.
I think it's fair to say that no customers were pestering anybody about Unikernels. I think that indeed this is like part of the problem. So you're learning about Unikernels. You kind of heard of it, but like seeing it, like, wait a minute, is this actually a thing? I would like to point out that they announced this acquisition. I actually asked the question on Twitter. Do I need to actually write a blog post about this, or can I let them be their own punishment? And which, admittedly, I'm asking it. I'm putting my thumb on the scale. I'm asking, the tribe. But the people, I think that there was a big exuberance around it, especially with the acquisition. And I do feel you had a lot of people who were in ops, software engineering, who were like, this does not feel right to me, but I haven't really thought a lot about it, and I would like to have some talking points. I felt like people were asking for air support for maybe internal conversations they were having. I'm not sure, that maybe reading too much into it.
I think that seems as credible as anything, just because on its face, the arguments at the time, I think, like a lot of these things in the Docker space, to me, didn't really add up. I didn't really understand the problem for which these were ostensible solutions.
Part of the challenge is that, and there's also kind of a definitional challenge, and then there is a further challenge that I think this just really attracts a false dichotomy a bit. And I'm realizing that, like, as I was kind of thinking about this morning as we were contemplating doing this, and realizing that there are certain words, certain prefixes that kind of lend themselves to overgeneralization and therefore are likely to create a debate that might have more heat than light. So, e.g., I'm going to put mono, micro, and now uni all in this category. So I feel that like
mono rail, 1 plus rail makes sense.
Mono repo, microservice. And I think that you could I actually think that you could create you could create an emotional reaction just by mixing these up Mad Lib style and just be like, hey, actually, we're going to all micro repos around here. Like, oh my God, wait a minute, what? We're going to the unirepo. Like it's a monorepo, but different. But I think that there are, in part because these are ways of, I mean, just tell me if I'm stoned here, but what we're actually, the part of the reason that there is a lot of fuss about this is because it is revisiting an abstraction. And it's saying, hey, the abstraction, the extant abstraction is the wrong abstraction. And I think that the abstraction should be radically, radically different. And the way I kind of embody that is with this ultimately like a tagline that is a good tagline. The Unikernel tagline is a good tagline. But what we are ultimately doing is questioning radically the abstraction. And I actually think there's some questioning in there that's good and some questioning in there that is not good. And then I think a lot of this does not have great foundation. I feel that like there's been some really good stuff done on unikernels, but then a lot of unikernel advocates end up, I think a lot of unikernel advocates, not a huge number of people, but there are unikernel advocates out there that undermine themselves because they don't tend to think about this with much nuance or rigor or kind of take these different things apart.
Yeah, that makes sense. And I think your idea about mono and micro and uni as being these shibboleths of reconsidering abstractions and appealing to especially to this notion of this thing, the kernel, say, has gotten out of hand. It's too big in particular. It's doing too much. It's too complicated. And let's get to something simpler, more comprehensible, more manageable, more secure, at least
let's
on its
throw
face.
The whole thing out.
Yeah.
Which I'm kind of like, I'm sympathetic to. I mean, obviously, as a company that is kind of throwing the whole thing out at some level, I'm sympathetic to, but if you don't understand why the thing exists in the first place, throwing it all out is perilous. You really need to understand why these abstractions do exist before you roll them all into the street, I think. I would also add that the suffix less is in this category, as in serverless. I think you could be repo-less. If I'm like, we're all repo-less now. It's all, have you heard? It's all about repo-less.
I just want to be clear. That is a made-up term, right? Because otherwise, take my money.
Exactly. And another one of these, and this actually gets to kind of the ancestry of unikernels, is the exokernel. Right. So the exokernel paper. Did you ever read this paper, the exokernel paper?
No, I haven't read that.
Oh God, it's a polemic actually. And what I later found out is it was like designed to be a polemic. The author was like, no, it was intended to be a polemic. It was intended to be provocative. Like, well, it was very provocative. Like that wasn't. I thought we were talking about this wasn't an actual proposal for a system, but basically the idea of the exokernel was that that applications want to handle some of these lowest level details, and applications want to have their own TLB mishandled, kind of like the canonical example, and that you may have a multimedia server that wants to have its own TLB load behavior. And I remember as an undergraduate reading this, thinking like, that's insane. That is turning every application into an operating system with all of its concomitant problems. And it's basically saying that, I mean, and I think I'm trying to think, why does this get under my fingernails? I think this gets under my fingernails in part because the abstraction that it throws out is the one that you and I have spent our careers in, more or less. And it's saying that like there shouldn't be an abstraction here at all. That we actually, operating systems as an abstraction should not exist, is to me what this is saying at kind of at its most polemic.
Yeah, I think that's right, and I think the reason why it is so viscerally tough to comprehend is because some of these abstractions I think of as so beautiful and so elegant and so miraculous. I mean, you talk about TLB mishandlers. When discovering the magic of virtual memory, there's just something so right about it that continues to feel so right about it. So to say this was the wrong abstraction and we should blow it up, especially when you're not really articulating a good understanding of what it is or why it needs to be blown up, it's a little tough to swallow.
It's a little tough to swallow, and I think especially because the pathologies that you're going to generate by doing that when you actually, like the bugs that you're going to have at that level of the system, like I want to change the fundamental abstraction of memory. It's like, well, okay, like definitely like admire the courage. Great, bold. When you get it wrong, the kinds of defects that you have are are really mind warping because you have fundamentally changed the abstractions upon which we depend. And now, I do a load and I get something that I never stored to that memory location because I'm getting someone else's memory. And how do you debug that? Because that is kind of this non-fatal corrupt pathology is really, really, really difficult to debug. So you've got to develop these systems really carefully and with a lot of rigor. And it's not something it's something that you want to leverage. It's not something that you want every application to do on its own without really, really, really good reason.
Yeah. So if I can pause for a moment, what made you think of this blog post? Yeah.
Right. Why are we here?
Hold on. Before we get into this, I need to demonstrate that I can criticize without, if I get fired from Oxide tomorrow. I have been a long time supporter of exokernels and such. So I have a little bit of the counterpoint to all these things. While I felt like I should raise my hand because we're a little on the these things totally suck. Why would anybody?
Yeah, totally.
Even think of
I'm glad. Yeah, good.
Someone who literally worked on a serverless platform to be like, "Lol, serverless, they're servers," is also kind of a little gets my goat slightly. So I gotta like stick a little bit here. I think so. Context: me and my friends in college, largely my friends, worked on an exokernel in D. And that was some of my intro to systemsy sort of work in an adult way, or in an adult age, I should say, rather. And that I'm a big fan of that. I think that the part of it is there's a couple different things. I think that it's rethinking the systems abstraction that all makes total sense. I agree with that as some of this motivation. I think another bit of the motivation for it is okay, imagine trying to make a Linux today as a hobbyist, right? Your surface area is freaking huge. So when you're hey, there's this style of operating system that basically does nothing, I think it's really, really attractive for greenfield development because it is conceptually feasible for an individual to write a container runtime, write an exokernel or a microkernel. And I'm not saying that a monolithic kernel is impossible, obviously, but when you start putting more and more things into the kernel, it makes it a much, much, much larger task and one that's kind of hard to move forward on. So I think there's sort of those things that I think you see a lot of the experimenting happening in this phase because it's just it's just a lot easier to do one of these things than not. But I think
I totally agree. Yeah, and I mean, and I think that there is this kind of there's so many layers of abstraction. And there's an idea that I want to be able to fit this entire thing into my head, and I can't fit this entire thing into my head with a general purpose operating system. And no, there's a great appeal to that. And I think that's part of actually what I think the disservice that I did to Unikernels, such as it is that I think that I probably should have spoken a little bit more to that appeal and that cognitive appeal to fit the entire thing, to revisit some of the things that have been done previously, abstractions that have been created. Do we still need those today? Can we revisit these? And can we shed some of these that we no longer need? Now, Steve, I've got to ask you.
There's two sides to this too. Real briefly before we get to that, because there's a little. Yeah. So I saw somebody recently be why does WASI use ePoll instead of a KQ or what's the new one? I'm totally drawing a blank on now. The
IO ring,
IOU ring stuff. Why wouldn't we just start with that? We have this opportunity, and I don't know specifically that particular decision, but this kind of happens a lot of time, right? Where you sort of you just WASI is sort of how do we get POSIX into WebAssembly? Let's start from that place and move forward or whatever. And so I don't know. I think the downside, as sort of mentioning in chat, is I sort of describe myself as a former champion of these things because I conceptually loved this idea, but I think that in practice it never really fully played out, and it's very difficult to even get started with or try. And so that's where I saw it kind of falter and die, even among somebody like me who is very philosophically predisposed to enjoy this kind of thing. It's was near impossible to actually try out and use with anything more than a hello world. I got hyper running on a rump unikernel for funsies, but I never did more than the hello world because even just getting that to go was pretty tough. And so I think that it was never really going to reach the level of mind share that it had to, because I mean, say what you will about stuff like Docker and it being hard, but at least it's easy enough to use that people use it and use it a lot. Yes. Regardless of objections to any sort of aspect of it, the systems design, at least it was developer user focused to whatever degree. You may argue it succeeded or failed, but they had a developer experience. Whereas unikernels conceptually sort of like never really got there exactly. So
Yeah,
anyway,
I totally
you can
agree.
ask
They
the
never
real
really
question.
spoke to the developer. So I gotta ask you, Steve, though, when you say you worked on an exokernel,
Yeah.
do you mean you meant an exokernel or a unikernel? I hate to do, I hate to do this.
I mean, we didn't get far enough for it to really matter, I think. Like, I think one of the last things that happened was like implementing fork or whatever. Like, we're like very, very, very not super far along. But like the intention was exokernel specifically. So,
Okay, because
that's
I
like,
mean,
yes.
this is where the terms do become sadly kind of somewhat important. Where I mean, I guess, but the question that I would have is in the kernel that you were operating in, were they all in the same memory protection domain, or did you have disjoint memory protection domains?
I
Did you
don't
use memory protection?
So like I think that we had not gotten far enough along in implementation for that to like super actually matter, but like conceptually the idea was like the kernel only handles permissions, like who is allowed to talk to what memory, and that is it. And so I think I would assume that if we'd gotten farther along, we probably would have, I would have hoped that we would do something similar to what we would do in Hubris, where it's like, you know, yeah, we do believe that this is fine because of static checks, but like let's also just do the actual dynamic checking because like that matters, you know, like we do like use the MPU, even though, you know, in theory, like, you know, Rust is good at that kind of thing, you know, you're just like, let's just like defense and depth it. So I would hope that we would have like also added memory protection, but like you're right that there is like a certain level of like extreme here where it's like it's almost like Midori style, like, you know, no, we're not even going to use any sort of like hardware protection about different memory domains. And
Okay, so
I think Spectre kind of killed that pretty much straight up for like everybody, right? So
so this is a good door to open because the I mean, you talk about Hubris. I would definitely want to get to our experience in Hubris. And you say that like, well, you know, we want to actually be extra sure. We were using a safe language, and that is true. Except even in our safe language, our delightful safe language, and we definitely try to avoid unsafe constructs. One of the things that I've definitely appreciated viscerally working on Hubris is there is in fact unsafe memory access all the time in the stack. The stack is like you can have an arbitrary, and I mean for us, like what is 95%, I would say, of Hubris task faults are from stack overflows. And it is from going deep in your stack. And you remember, Steve, when we started, we had switched where the stack and data was. And when you would overflow your stack, you would run into your own data and then run off again. And we're like, why are we having memory corruption problems in this like safe, we're using a safe language. Where is the memory corruption coming from? But it's coming from stack. And I feel that like that is as long as those, and I think that like, I mean, it'd be interesting to know if people have kind of considered this rigorously or theoretically, but I think if you have a stack in a language, I think it's very hard to make that stack access entirely safe because that involves reasoning about what your program is going to do. I think you have to solve the halting problem to know how much stack space you're going to consume. Adam, is that a
Rusty and standard library like include stack probes specifically to see if you underflow the stack, right? Like this happens even in bigger devices or whatever as a defense mechanism. Sorry, Dan, you're about to say something.
I mean, here's the thing. I don't think you have to solve the halting problem because your operating system kernel is necessarily a restricted execution domain, right? You're not running arbitrary code in the kernel, generally speaking. And even if you are with something like, eBPF, like there are restrictions on that. Right? Like loops have to terminate and so forth. So I think that you're solving any number of halting problems, but you're not solving the halting problem in general. And I think there is some prior art here. Like if you look at the Biscuit kernel that came out of MIT, which they wrote in Go, they were very concerned about like, hey, what happens if we execute a system call and we don't have enough memory to satisfy it? Like, what do we do? Are we going to take a GC in that hot path? And they did a bunch of like static analysis of every system call path and said, actually, the maximum depth of the stack could be X, and we're going to make sure that there's sufficient memory available to satisfy that on entry into the kernel. I think there's nothing that precludes you from doing that.
Well, but keep in mind, Dan, we're talking about but true, but that's assuming that the kernel is in an orthogonal protection domain, which it's not for a unikernel. In a unikernel, we are all in the same protection domain.
We are
all string operating.
Define unikernel. I almost disagree with that too, because if your constellation of unikernels running on a system are running under a trusted hypervisor, then they are kind of in the same protection domain, right?
Well, in a unikernel, there is only one protection domain.
Okay, but what does it mean to be a unikernel, and what is that executing on?
Well, I mean, I think that actually the way I think that they would define it, or the way that it is defined, a unikernel is defined really in terms of the abstraction, namely that there is not a system call boundary in a unikernel. So all execution is privileged. Now that privilege may be living in a virtual guest. It may be way in the stack, but you are sitting, but you do not have different levels of privilege within the system.
Oh, okay, but like, and to some extent, this is a distinction without a difference, though, right? It's like if I am running that under the aegis of some hypervisor that enforces boundaries on what the unikernel can actually access, then what, like is that a big deal? Does that matter?
Sure, because it means that when I've got my rump kernel with MySQL and MySQL overflows the stack, the whole system dies.
Okay.
Or corrupts itself. Worse, corrupts itself. My MySQL overflows the stack because there's no memory protection. It actually overflows my TCP state. Into my TCP state. Corrupts my TCP state.
Yeah, I
so yeah. So now instead of having an application that dies on a Stack Overflow, I've got a system that is now behaving corruptly because it's had data corruption. So yeah, there is a difference.
Okay. All right. Fair.
And I mean, like, I think that like this is indeed like one of the thought definitely occurred to me, especially as we were playing around with talk. Adam, I don't know if the thought occurred to you that like, God, this would be, I know the gods love to amuse themselves with their irony about my life. And it would be, if the gods have sent me to go work on a unikernel as a punishment for my blog entry, like I admire them. Because when we were considering talk, like talk does not have, we're all basically in the same protection domain with talk.
So you think of talk as a unikernel?
I should stop short of that, but I think that like what talk has done with their modules is you got it's a modular kernel. I actually don't want to get too caught up on talk itself, but I think that I think emphatically hubris is not a unikernel.
Wait,
but
Brian,
hubris,
you just yelled at me for saying that that the stacks-based thing in hubris is addressable, and you said no. Wait, well, what if I'm running MySQL on my unikernel? Like what?
No. So sorry, and maybe
right.
pass one another. What I'm saying is that even in a safe system, you have effectively unsafe memory accesses, and why it was very important in hubris to make sure that when the stack overflows, it hits a protection boundary and the task dies.
I think
that's right. So you can a task. Go ahead, Dan.
I think what I'm trying to say is that you can construct a safe system where you don't have unsafe stack accesses.
Maybe, but that's not the system we're in.
And Dan, you think that that's because you can do static analysis to understand the maximum bounds of stack consumption?
Yes.
I guess I don't have any experience with those kinds of systems, but my intuition about some complex systems that I've worked with is that the maximum stack depth is far greater than the practical stack depth. And so you may end up dramatically over provisioning the system. So I'm not disagreeing with what you're saying, but I think in practical terms, you may end up wasting more resources, and instead you kind of put a finger in the air and decide that your stack is only going to grow so much, even if you can't prove it.
Yeah, I mean, like go back, like I think something that we're not really talking about is that a lot of times as kernel developers, we're used to living in this world of very small stacks, like in some cases 4K small. And if you go back to like BSD Unix, they had to deal with this. And 4.4 introduced red zones underneath the U area, or in between the U area and the kernel stack, so that you would take a page fault if the stack descended and was about to overwrite the U area. I guess what I'm saying is, like, I think if you're writing kernel code, you become accustomed to writing code very carefully so that you're not, putting too much stuff on the stack.
Sure. I mean, but our own experiences with hubris are that even when you're writing code carefully, and because you're also trying to, I mean, this is the kind of, when you're in a resource confined system, you actually want your stack space that you use to be as trimmed as closely as possible to that which you're actually going to use. And these things are in tension. Because it is hard to reason about the ultimate depth in which a thread may descend with respect to stack. And to me, it feels like it's close to the halting problem. Maybe it's not, but it's really hard to actually reason about. And that kind of dynamic behavior is part when you don't have protection boundaries, and when everything can kind of grow into everything else, it makes it really, really, really hard to reason about the ultimate system. I think that's does that make sense, Dan?
Yeah, oh yeah, sure. I mean, it makes perfect sense. I think there's some definitional issues here, because it's like when we talk about hubris, it's not a like you're not running a general purpose workload on that system. Like every bit of code that's going to run under hubris is compiled into the kernel image itself.
Well, and so
that's how unikernels would be used as well, is that you compile your program into an OS image. I'm not saying the hubris is a unikernel, but I'm saying that part is not why it's not.
But
but this is a really important point, because I think that hubris splits this kind of false dichotomy, and I think that hubris shows to me that so I think one of the things that people like about unikernels is the delivery vehicle. And it's like, hey, you can have the delivery vehicle without actually giving up your protection boundaries. You can actually, there are different ways to turn the dial. And I think that like part of my visceral reaction to unikernels is they're trying to turn every dial in its most kind of extreme direction. And it's like, actually, you don't need to do that. And you can take like a hubris approach where we are going to, I mean, very importantly, like there is no fork and exec on, we cannot execute arbitrary processes in a hubris kernel. We can only execute those processes which were created at link time. And that's, I mean, hugely, hugely powerful. And I do think that and so to me, that it's important to kind of split some of these things out and find some of these different ways of combining a system that don't give up what we need to actually deliver a robust system.
Can I interject at this position?
Please.
Sure.
Please.
The one patch I have for this unikernel idea is if system understood small model of processors, not actual processors, becomes easier to write as different kinds of code become easier to write with better tools and all that kind of stuff. At some point, we might want to be in a position where the elders made some wise decision about the ABI or about the kernel or about how many layers of indirection we need in case we have this kind of miss. But at some point, we might want to be able to tweak those changes. And the question is, what kind of environment can one run such experiments if one only has time to write run operating system, not 15 for every variation one wants to try? And basically, the thing you did is that there might be unikernel sort of hiding in hubris, but the complete text surfing kernel got linked away into something which makes user processes wrapped in memory in safe memory regions, and that unikernels are an experiment vehicle which we sort of have to create because we have no idea where to start with regard to how we make our operating systems better. But
well, I think
that's the best
an
pitch
idea.
I can give for it. That's the best pitch I have for it.
Yeah, well, I think that is like, this is the reason that radical ideas are always like intriguing and important at some level, because they do force us so far out of where we are that it does force us to kind of question everything, which I think that is good. I think that is what makes it interesting. And I actually think it's really valuable for that kind of experimentation. I think that the thing that does get frustrating is, and Steve, maybe it'd be worth getting back to kind of your kernel to understand how you dealt with this, and certainly we can talk about what we did with hubris. I mean, the thrust, I think, of my argument against unikernels is that they were dismissing debuggability entirely. And I do think that when you are in a system that can't execute de novo processes, debugging becomes really tricky. And you really need to spend some hard time thinking about how you're going to debug the system, because we actually do have unikernels that are in the wild. It's called firmware. Right? I mean, basically every firmware payload out there is effectively operating as a unikernel right now. It is not every firmware payload, but if you go to your disk drive, if you go to many different components in your machine, there is a little operating system running on there, often without protection boundaries, being delivered as a unit. And anyone that develops embedded software would tell you that like debugging that thing is tricky. So I think and Adam, I know this is very near dear to your heart as well. So it'd be interesting to know how much those debuggability arguments resonate.
No, I'm with you. As I was thinking about some of your arguments against unikernels, some of it comes down to values in the philosophy there. Not so much denying experimentation, but rather saying, what are we throwing out and what are we valuing? And so, I particularly like your discussion of the zeitgeist around if something is broken, we just restart it. We don't care about what happened. We just want to restart it. I think I think we talk about peak Docker. I think that really was, deep in the zeitgeist at that time. And I think that's evolved a little bit. I think we've retreated as an industry a bit. Maybe this is too optimistic, from the just restart it mentality to one of understanding or knowing that we need to understand these failures in order to build more durable and robust systems. That's something that seems to be absent from the unikernel philosophy.
I got half a comment, half a hot take on this topic. I would say the comment is that I think that the ideology that at the time that I remember is like, you think of it as like a cross compilation target. So like you're trying to debug it, you're debugging it on the host, you're running it on your actual computer. And that this is like a deployment strategy. Obviously, like those things are never one-to-one, but you're sort of like, once you're willing to do that, like that sort of like the same idea as like using friggin', oh God, why am I totally drawing a blank on literally the most famous database ever that runs in a file? I swear to God. SQLite. Wow. Like it's like SQLite in development, but Postgres in production, right? Like obviously you're gonna have some problems whenever those things have different behavior, but like a lot of people test in one way and then deploy in a different way. And so I think that the argument for debugging was not that like we don't care about it. It's like you're asking it to be done in a different place. I would say that like the ideology was closer to a like debug on the host and like not worry about it in production. But I think that like a slightly more deeper, more accurate take would be like, unikernels are like delivering some sort of software that's written by some other platform. And most of those other platforms, I don't think have a debuggability value, to sort of put it in the terms Adam used, because I really like that you all have. Like, like you all are like further along on wanting runtime debuggability than any other people I've ever like met in my life. And I say that with love, and it's a good thing, not a bad thing. Just like if you're
us now,
like,
is it
I
like,
see that as like, okay, so you're deploying a Rails app as a unikernel. Oh, it's like I can't debug a Rails app. Well, it's like that's more of a fault than Rails than of the unikernel, I would argue, if you're gonna like try to assign fault as to why. But I will say that on the like sort of to also piggyback on Adam's like maybe this is the optimistic kind of path, I think that so some of this attitude also, at least in the web dev space, comes out of the idea of like, if I'm SSH'd into a machine, that means I'm treating it like a pet, not like cattle. And therefore, like, that's like not appropriate. And we need to get away from that as much as possible. But like, then people realize that it's really hard to figure out what the F is going on. So like, that's why you see all the like rise of like tracing and, all that kind of like, those sort of necessary tools are kind of like the natural swing back towards like, yeah, like I'm not trying to SSH into this machine, but like also I do need to know what happens to figure out like what's causing this problem. And so I think we're just kind of seeing the natural sort of tick and talk on these sort of things. And so I would say like, that's my take anyways. Like, I don't disagree with you, but I think like the sort of blame lies elsewhere, and sort of that general attitude is like also a broader one than like specific to the unikernel stuff. That's all.
I mean,
yeah, that's Steve. I like a lot of elements that I want to go tease apart. One is this idea of I want to be able to interact with the system dynamically by creating processes, not to mutate its state, but to understand what it's doing. And I think that there's often Because I think you're exactly right. When people think like, if I can SSH into a system, then it is a pet. It's not cattle. I don't have a mutable infrastructure. I mean, there's a lot of value to having a mutable infrastructure, and I think there's again a bit of a false dichotomy there. But I do think, and Francois, I hope Francois is currently dropping hot takes into the chat. I hope he's going to jump up on the stage here, because the saying that I actually do think that firmware is hard to debug by nature. I think embedded systems are hard to debug by nature, and I think that it requires more attention, not less. I think the tooling is historically not good, not because people don't care about the problem, but because it is you have to care about the problem even more than anyone else, because it is so hard in an embedded system to be able to debug it. But that's a hot take to get Francois up here, because that's what Francois's company currently does.
I'll take the bait. I'll take the bait very briefly. Hi, I'm Francois. I make debugging tools for firmware, so I have opinions. I think, having worked on firmware for a while, but also nowadays building web applications, I think fundamentally debuggability is a function of your runtime. Echoing the point that I think it was Dan made about, if your Ruby on Rails application, your unikernel isn't debuggable, like blame Rails, not the unikernel. And when it comes to embedded systems, what's your runtime? I would argue it's three things. Number one, it's the application programming interface of your chip. So whatever facilities ARM provides you. Number one. Number two is your libc, which provides some facilities, and number three is your operating system. And ultimately, I think all three of those have exposed ways for us to do our job and debug our systems. And we've done a terrible, we actually haven't cared, right? Like, for example, CoreSight has been a part of all ARM chips for a really long time. It is extraordinarily powerful. It has lots of warts. It's not a perfect system. But nowadays, with modern, like the newest revision of CoreSight, you can basically stream, you can trace sampled program counters to a buffer in RAM, and then extract that and do as good a job profiling your application as you would on I think a modern Linux system, more or less. Nobody I know uses it. Nobody at all. And so
almost nobody. Well, so
almost
actually,
nobody.
I mean, it depends if are you talking about ETM? Are you talking?
I'm talking about ETB, which is the embedded trace buffer.
So ETM, I'm convinced I was like the first human to actually try to make real use of ETM, and ETM is the embedded trace macro cell that's present in the Cortex series, and it's extraordinary. They don't use it in the M7. It's gone. It's like
because nobody uses it.
Because nobody uses it.
And most of the semiconductors don't implement it. But the point I'm making is, when tools are built, they're not being used. And if you look at, your OS layer, which I know we all love hubris here, but still FreeRTOS is maybe the 900-pound gorilla.
Yeah.
FreeRTOS has awful debuggability, not because it's not possible to do, but you just haven't prioritized it. And of course, if you peek under the hood and you look at their data structures, it's piles of macros on top of each other, mostly in order to deal with some Misra compliance misery. And the bottom line is the point I'm making is I would argue that if your system has poor debuggability, it's just that nobody has cared to build good debuggability. And I have yet to see, someone build something amazing to make their, database debuggable that you couldn't build on an embedded system or in a unikernel environment, not being an expert, with a little bit of work. That's what separates amazing from bad, is just work, not structure.
Sure, but
I
do you think in an embedded system, though, you don't have, for example, SWID, which is the single wire debug, which is what allows you to control heaven and earth with the Cortex series. You actually don't have that in your embedded system, right? Which makes it does make it more challenging to debug those things in the field, don't you think?
What do you mean by you don't have that? You mean you don't have it when you're remote?
Yeah, I mean, well, I'll just tell you, I mean, our experience is that we have gotten, I mean, we've built a lot of tooling around the SWID functionality. And when we actually get these sleds loaded into the rack, like we're not attached to SWID. We are actually debugging this thing over the network. And one of the things that we actually, I don't know if you know what we've done with our root of trust, this just delicious innovation due to Rick and Laura and Cliff and Matt and a bunch of folks, is having the root of trust actually has the SWID lines to the service processor. So the root of trust, which is because the root of trust can actually control the service processor. And so we actually use that to take a dump of the system. So we can take a system in the rack and we can have the root of trust stop the service processor and take an actual dump of memory. It is a little bit surprising. Maybe Francois, you can shed some light on it.
But it sounds like you solved your problem, right? Like,
oh, for sure. Yeah, for sure. I didn't mean that it was impossible. It was just it was just tricky.
But it's tricky because nobody's cared to build it. If this were the Linux ecosystem, or if this were the JavaScript ecosystem, you would have just plugged in a library into your root of trust. You would have imported cargo added via cargo to your project a library that just does this, and not thought about it. There are JavaScript debugging libraries that do crazily complex things, and we don't think about them much because we just npm add them and then move on with our life. It's a community problem, it's an open source problem, and it's a dedication to the craft of building tools problem, not a essential complexity problem. I think, and in fact, to your thing about the SWID lines, yes, still the hardware world is very hardware focused, making debugging hardware first. But you can also use, the debug and watch point trace units to basically build your own software debugger for your firmware. Again, nobody's built a great off-the-shelf open source library for it, but you can.
Yeah, that's a really good point. I mean, I do think and Adam, I don't know if you've looked at the debug facilities that exist in the Cortex series. There are actually some really good hardware debug facilities that I have the same reaction that people don't seem to be using. Which is kind of tragic because you've got things that I would love to have at the kind of the host CPU level that we don't have. And it is incredible tools. But I do think that and again, we would disagree to disagree. I think it is in these embedded systems, it is harder that there are limited interactions with the outside world. The limited level at which they can be dynamic makes it harder to reason about when they are misbehaving. You're going to have to use a different set of tools, and in part also you have to use a very different set of tools in development that you're going to use in production for these systems, which maybe is true for lots of systems. But
I think where I'm happy to leave it is it's hard, but 80% of the reason it's hard is that there's just nothing out there, no community, nobody to help you, no blog post to read, and 20% of the reason might be essential complexity. And so I would say if we try to bring back the metaphor or look at what we can learn from there and apply it to the topic at hand, which was unikernel, we might say, okay, maybe we think they're hard, not because they're essentially impossible to do right, but rather because no community ever sprouted and the UX sucked from the beginning, so nobody wanted to be part of that community. And the human story is oftentimes the more interesting one.
Yeah, I think that's fair. I mean, because you say that if it's a Linux, you just use a library, but it's GDB. I mean, you cannot be a fan of GDB. We can do better. GDB is. I mean, I don't know. Maybe you love GDB. I find
we
GDB,
must do better.
Right. Exactly. And it should be said. I mean, this is what you. I mean, this is the genesis of Memfault, right? Is you getting frustrated that teams are having to reinvent things every time they do a new system. Am I saying that correctly?
Yeah, you basically kind of set me up here, but bottom line is, I was looking at my friends who were building cloud applications and were able to log into a dashboard and find out whether their system was working or not. Forget about why it's not working. Even figuring out whether your product is working or not. You could somewhat figure it out for some dashboard and might get an email or a PagerDuty alert when it doesn't work. And I was toiling away at devices like the Pebble Watch or the Oculus virtual reality headsets, And the only way I found out that they were broken is people called me. I received 1,000 emails because we shipped a bug in a firmware and customers noticed. And I thought there's no essential reason why this experience as a software developer is different. There is the only reason is investments in tool and habits of building tools as well as building products. Something Oxide has been doing super well, right? Like building tools alongside products. And so I thought, I'm going to start building tools for my products, and it spiraled a little bit out of control, and now I'm running a tools company. But I think the essential thesis is that there is no essential reason why firmware cannot be built like software with the debuggability, with good tools. And I continue to believe that. I've been doing this for 4 years now. So it's
and so on unikernels, then, so your belief on unikernels, I mean, if you using unikernels as kind of an approximation for firmware, because they share a lot of things in common, your belief would be, hey, this is in unikernels, there's nothing that makes this impossible. It's just that the time and energy has not been spent.
Exactly. We just haven't had Solomon, the founder of Docker and an incredible engineer who said, I'm going to build an ergonomic system to use this technology and good tools alongside it. And that's often the difference between vibrant ecosystems and really crappy ones.
First of all, I think you're spot on. And Brian, I was just thinking about, if the unikernel manifesto had included, also, if there is a problem with the unikernel, we don't just restart it. First, we capture its entire memory state, bundle it up, put it somewhere for your later analysis. I think that might have changed at least how I thought about them, or how I viewed them, or how they were regarding the need for robust, building robust systems. What do you think about that?
Yeah, I think it'd be interesting. I think that would also likely be a consequence of someone trying to actually use it to build a broader system. I mean, I think
that's right.
I mean, kind of my other frustration is that it's like, hey, go build something with unikernels. Great, this is the right answer. Go build with it and show us all. And I think that we saw that with Docker, where we could actually the tooling made it delighted developers. To Steve, to your point, Francois, your point, that the tooling was superlative, and it showed, and people could develop things faster. And I think that with unikernels, that ended up being more rhetorical than demonstrative. And I think it was.
So there are a small number of systems in the world that do actually build things in that way. I worked briefly on a radar signal processing, and they were actually using the speed of the cycles on the CPU to do time of flight radar. So they wanted it to be pretty well real time. And that thing had no operating system. You compiled directly for the chip, and it knew what the size of the stack needed to be because you were not allowed to have cycles in your call graph. And it said, okay, here is the maximum depth of the call graph. And if you're going to blow the stack, that is a compile time error. But it was a real pain to work in that environment because, sometimes it's nice to have cycles in your call graph.
Yeah, interesting. So this is going back to kind of our earlier discussion about, can we reason about stack depth, and is stack depth knowable? And so you're in an environment. What's the language in this environment, by the way? Is this assembly? What is this?
It was a language that generated C code that then got compiled to the chip. So it was sort of a C-ish thing that was specifically for targeting this one chip that was used in this one radar use case. And to the best of my knowledge, the language was never used on any other.
Interesting. Are you putting language in air quotes when you were saying it, or should I be putting it in air quotes? It feels like it's, but interesting. So that, that sounds like a tantalizing application for sure. And so there are basically just to Francois' point about this tooling coming from the system itself would impose these that you could not have a cycle in your call graph, for example.
Well, it was the compiler that was enforcing it. There was very little security on the system itself. The philosophy was that the place where we put the software on the chip, there's a guy with a gun who won't let you put on anything that's not approved.
And any Misra certified firmware has pretty much that constraint, right? If you're building firmware for a car, it most likely needs to be ISO 26262 compliant and needs to be go through a Misra linter who will yell at you if there's any cycles in your code because it actually wants to solve for how much stack depth you have. In other words, you can build a runtime that will make it so that you don't have to solve the stopping problem in order to reason about your stack depth, but you might not like it.
Right. Right. Well, and I think this was a big eye-opening for me when I was an undergraduate and I was working at an operating system company, QNX, at real-time operating system, selling into all these hard real-time customers and learning about all these things like rate monotonic analysis and all this kind of academic real-time systems, and then learning that like, oh yeah, no, we don't. Sorry, no one does any of that. You actually just beat on the system until you have confidence that it's going to meet its deadlines. It's like, oh god. It was eye-opening. It was revealing about, it was engineering versus academia for sure.
Different than any other operating system project you've ever worked on, like at all?
In terms of like being, well, I do actually feel that like I think that, and part of what I love about Rust is that you actually do shift a bunch of that cognitive load, and you do actually get, the compiler helps you out a lot, and the compiler can tell you a lot about when you have got something that would be potentially misbehaving and doesn't let you do it.
Well,
I mean, first of all, one
sure.
question I have on Misra is there, are you seeing any, I mean, because Rust is actually in the limit a great use case for these hard real-time deeply embedded systems, but I'm not sure if Misra is quite caught up to Rust in that regard.
No, I'm not. As far as I know, the only effort that's getting us slowly closer to that is the folks at Ferris Systems have spun out a group that's trying to build, I think they used to call it sealed Rust. I don't know if that's still what they call it, but trying to build a basically documented enough and verified enough Rust compiler that it could then be used in safety critical application and go through all of these different requirements. Whether that's Misra compliance or, the FDA also has a concept called SOUP, like software of unknown provenance, which specify all these things you have to do to include a third-party library or use a compiler or something like that to build a medical device. And by the way, really well thought out stuff, huge emphasis on the actual risk. So if you build a device that just measures your is like a wrist-mounted tracker that measures your blood oxygen level for, day-to-day use, the requirements are much looser. And if you're building a pacemaker, the requirement and failure of the device can cause grievous harm, the requirements are a lot stricter. And I was neck deep in this all of last week, so I'll leave it at that. But long story short, it's going to take a decade before. With good reason, by the way.
Good reason. I was going to say
it's going to take a decade before
right.
you see Rust in a pacemaker, maybe longer. And while I'm talking, I'll pose one question back to you, which is: do you think the best technology always wins? Because I think that's at the root of the question about this, like Docker versus Unikernel versus whatever. Ultimately, we're arguing technical merits, but in my experience, it's not the best technology that wins. There are many other human factors that have a much stronger influence.
I have a hot take on this, but I also just want to say it's called Ferrocene now. Sealed Rust was the old name. You're correct about that, but Ferrocene is the current name. Just yeah.
But then Steve, then you got to drop it. You can't just be helpful. You got to drop in your hot take, please.
Okay. The hot take is, if it doesn't actually help people, like marketing factors are real factors, and that means it's a worse technology. It's not better absent in some like abstract sense. You could be like the quote unquote best thing in a vacuum, but if nobody can use it, that's not just a human factor. That actually means it's a bad technology. So I kind of think that like best technology wins is like definitionally correct. Basically,
if you define best technology in an amazing way, which goes beyond the like, engineers arguing in their or scientists arguing in their papers. Yes.
I mean, I think that whether a technology quote unquote wins or not. First of all, like I do think that especially in a post open source world, I think that we should not merely think in terms of winners and losers, and because I think that technologies can survive in perpetuity with a limited audience, and that's okay. That's good. I mean, like SEL4 that's not a dead technology. That's an important, vibrant technology, but it's one that's potentially small in terms of the folks that are using it. So I think that we don't want to necessarily think, but I also think that the kind of the ubiquity of a technology is only related in certain regards to kind of its purely technical qualities. It is definitely related to how it actually meets the user. And I do think, I mean, Steve, Rust is kind of an interesting one because, I mean, Rust is a language that is enjoying more and more popularity and is a really good artifact, is really technically rigorous. I mean, I think if anything, I mean, I think Rust should give us some solace and confidence that a ubiquity of a technology does not necessarily mean that it's mediocre. I think there's been kind of this idea that like, well, the best technology never wins. Therefore, any technology that is ubiquitous is crap. And it's like, well, not necessarily. Maybe some a technology can have ubiquity and still be pretty great. I don't know.
Sounds good to me. I don't know. I guess I wouldn't argue that like good technologies are actually crap. So it's hard for me to say anything other than like, yep, I do think it's nice when something that's popular is also good.
Steve,
yeah, totally.
what is the turning point for Rust, do you think, by the way, where I know it's hard because of someone who's been, close to it for a very long time? Because one thing you look back at this kind of unikernel fever in 2016 and some of the problems that it identified around surface area and around burdensome complexity and so on, I do feel that some of those problems were actually addressed by Rust at some level. And I do wonder, does the rise of Rust kind of show that the world has found different ways to solve some of those problems?
Yes. I think I thought I was going to answer the start of that differently than I am at the end of it. So that's my funny, silly answer why I'm starting that like a little different. I think.
Can I choose your own adventure? Can you give us both answers and then we can kind of choose which path to go down?
I don't know. I just think like it's hard. Like I think Rust is successful because of taking certain things technically seriously, but also taking things like socially seriously. And I think that there was a lot of good sort of like low-level programming languages that could have been more successful, but ultimately weren't because they missed out on a lot of those kinds of sort of the rest of the zeitgeist, if you will. But that's sort of a little, I don't know. I feel like I'm like going super, super way off topic or something. So.
No, I don't. Well, I don't think this is off topic because I think this is all around kind of like how we think of abstractions, and I think then how we also affect change in those abstractions. Because I think one of the way, like, why and how has Rust succeeded in kind of changing our abstractions, and a bunch of these unikernels kind of didn't, despite some initial enthusiasm.
So personally, I have some theories about why Rust is successful, and I think they, in a sort of self-serving way, it's kind of like, this is the reasons why I decided to work on Rust, and therefore it was successful. So of course, I think those things were sort of the reason why. But like, part of what drew me to Rust in 2012, and what still does to me today, is that like, Rust sort of like, I don't know, it kind of like, okay, so I was like, this language seems good on like its own sense. Like I like ML sort of things. And I thought it was sort of like a well-constructed language. But then I saw that it had the backing of Mozilla. And that meant that there was like money to pay people, because it turns out that like building a production ready language these days is a Herculean effort and requires lots of people and therefore either time or like money in order to get more people to work on the thing. And so I was kind of like, okay, both of those things make this seem feasible. Like, because there's a name behind it and because there's a budget behind it already, that's like a super, super huge indicator of success. And there's a lot of folks who sort of have that question about programming languages in general. Like, can you really build, like, to what degree can the like what happened in the 90s where all those languages were like one person was like, I want to make a programming language, and now billions of dollars of the world economy relies on what was originally somebody's hobby project. Like, can you still do that now is a question that sort of programming language people debate. But at the time, I definitely like think that it was definitely a positive. So I think that has like really significantly helped Rust be a thing. So I think that's a large part of this kind of like why people use these technologies and like non-purely tech factors that come into these things being successful, for me anyway.
Yeah, that's interesting because I mean, this obviously created a bit of a self-fulfilling prophecy in that it attracted enough people like you, even those kind of early days, that like, hey, if Mozilla's backing this, my efforts are not going to be for naught. And then those efforts, of course, because I was not attracted to Rust at all because of Mozilla. but I definitely was attracted to it because of a bunch of the maturity that was now in it and how practical it was for solving real problems. And I think that, I mean, that pragmatism is something that I always look for in a technology, because it shows that, to me, something that's very important is that a technology is being used to solve actual problems. And it's not being done for its own sake. And maybe, Francois, this gets to some of your questions about like this idea that technologies that are being done for their own sake then not being used. It's like, well, you've got to actually, you've got to develop it as you use it. That's how what leads to the best possible artifacts, I think.
Building products and tools together, I think, leads to the best outcomes. But beyond building, thinking about trust, I think, Steve was talking about Mozilla. I would call that like trust, right? Distribution, price. I think there are many, many technologies or software packages that won out because they were free versus others that weren't. And you might call these like part of what makes something the best technology, but I think they're distinct from the purely technical. And I think when we argue about the relative merit of a trend, we should think about beyond the purely technical aspect, but is there, trust? Is there distribution? Is the price right? Is the code of conduct one that you want to attach yourself to? There's many, many more things that go into making a project successful. And I think that the way Steve talked about Rust resonates a lot with me, because ultimately none of the things he mentioned were technical. They were really like human factors. For me, what attracted me to Rust was that it explored a problem space that like felt new, that it wasn't accessible to me before Rust. Because I work in the systems space, right? I write bare metal codes. I don't have a lot of choices when it comes to the tools that I use, and a programming language that opened up like new options and explored new ideas. Even if maybe I'm not an ML or a programming language researcher, so they might have been old ideas to some, but to me they were new ideas, and that was really exciting.
Yeah, I feel the same way, and I feel that just bringing, some types I had not used as living in the ghetto of C. I had not really, and totally changed. It was not the reason that I first started dabbling with Rust, but kind of the first impression that I had. And again, you immediately see that pragmatism, which I do feel is, that to me is lacking from some of these unikernels. Now, as someone had asked in the chat about Mirage OS, I do think Mirage OS is by far the most interesting. Well, you got Mirage OS is definitely an interesting one. I think rump kernels are interesting, and it sounds like, Steve, that's kind of the origin of the D-based system you were dealing with, was a rump descendant. Yes. I think part of what makes this a challenge in terms of defining unikernels is that they actually are pretty different from one another. Mirage, you can't have everything in Mirage is in OCaml. It's very much bound to the language, versus in rump you could do things that are a lot more arbitrary, but then you kind of have to port them into rump. So
I think this is a great way to tie the two things together, though, because like I was thinking about this a while back, is like that's part of, I think, the issue is that like the canonical best example of unikernels is tied to a programming language that most people sadly don't use or know. And so like it's just inherently, because it's like it can only ever really attract part of the audience of OCaml folks and not like everyone who's building web apps. And so like that's like kind of the tooling missing that human factor or whatever.
Totally. And I think then you need some value that's just going to be like off the charts to really draw you in on that. And I think that Mirage, to its credit, is like still around and people are using it. And I actually love I was reading a recounting of a Mirage meetup, and they're just talking about all the things they're actually building with it. It's like total admiration for it. It's open source. It can
sometimes people are like, I wish there was a Rust but with a garbage collector, and it's like OCaml's like crying in the corner like, I'm right over here, everyone. Like this I've been here a really long time just like waiting. So like if you've ever wondered like, dang, what would Rust with a GC be like seriously, go try OCaml. Is it exactly Rust with a GC? No, but like it's the closest thing that exists.
And Steve, are you? There was someone in the chat saying that OCaml is getting a bit of a resurgence now.
Yeah.
Do you think
recently OCaml achieved something they've been talking about for like 15 years and then finally actually did, which is making
right?
multi-core work well. Yeah, so totally. I mean, definitely it's got a lot more of attention. There's also just in the last, I would say 5-ish years, it's also gotten a really big boost, like with Facebook writing a lot of like tooling that folks in the JavaScript ecosystem would use was in OCaml. I think they've sort of moved away from a lot of that by now, but like that definitely was you had like, was it the Reason compiler was written in OCaml? A lot of the stuff that's like programming language related stuff at Facebook is in OCaml. So yeah.
Which is great. I mean, because I do think that, I mean, something I don't want to lose in this. I mean, you don't want to become, I mean, God, I mean, I know we were talking about earlier today, but Bjarne Strostrup's piece on safety that was picked up today is just, Adam, did you read this thing? I don't know if you saw this.
No, I haven't seen it.
Oh, brother.
Oh my gosh.
It's just like, you just don't want to sound like this. You just don't want to be, I mean, it just comes across as, I mean, Steve, what's the final line of it? Do you happen to have that?
Oh, there's two versions. There's two versions of the paper actually. And the first one is a small one just by Bjarne. It's two pages long. And the final sentence is, and anyway, what is, quote, the overarching software community, unquote? To the best of my knowledge, no experts from the ISO C++ standards committee were consulted. Which is like, this is like about the government saying like memory safety is important, and they were like, everyone says we should move away from memory on safety, and like that's the like response. But there was also a longer 10-page version of the paper which does not have that language, but is a lengthy description of the way they think C++ should orient itself towards this topic in the future. Yeah.
And they keep misspelling Rust, which is awesome. Seemingly deliberately.
Oh, he's spelling Rust in
all caps.
Yeah, all caps. Just like kind of because, right? Which seems
why
like
are we screaming Rust time? That's I mean, I do think is, and especially as one is deep in one's own technology, it can be kind of tempting to dismiss all others, and I think one wants to, I think, and I think you can argue fairly that maybe I fell into that trap a little bit with this unikernel polemic from 7 years ago, because I do think that there are, I mean, I think, and Adam, do you remember my idea of having a conference called In Retrospect, where we revisit past talks?
Yeah. I think kind of the pair to systems we love. Yeah.
Yeah, right. Would that be good? Where people like have, hey, I want to I gave this talk 7 years ago, and now I kind of want to talk about how my thinking has changed a little bit.
Yeah,
and
that'd be great.
I think if I were to give that on unikernels, I feel that the bit that I would expand is that there is some interesting bits here around the unit of delivery that I think is actually really important. And I think that finding ways to achieve some of these goals. And I think, Steve, to your point about just eliminating complexity. I mean, there was I gave and Adam, you may remember this talk because I quoted Leventhal's conundrum in it. Leventhal's conundrum. May I attempt to explain?
You coined Leventhal's conundrum. Yes.
I don't think. Yeah, I can't coin Leventhal's.
You described it to me. You described it to me. I appreciate it. Yes. No. You were the one who gave it the name, and I greatly appreciate it.
Which is when you are looking at a pathologically performing system, you are given the hurricane and you must find the butterfly. Right? Is that?
Yes. Better articulated than I think I did in the moment when I was beating my head against the hurricane.
And which something we do a lot, and we're kind of dealing with the complexity of the system. And one of the questions that I actually got, that talk was recorded, but the question and the answers were not. And I really. I guess I'm both glad and I regret it, because there's a question that I would love to take back. I was asked, do you think that complexity, that we're going to have less complexity in our systems, or this complexity you talk about, the emergent behavior in the systems and how complexity has grown, is there going to be anything that actually reduces the cognitive load? They didn't phrase it exactly this way, but it's kind of what I inferred. And my answer was basically like, nope, it's just going to get worse. I mean, it was just like and there have been so many, and that kind of talk is like right before I really got into Rust. And I wish I had been I'd been looking around a little bit more to be like, well, actually, there are things out there. I mean, including OCaml for that matter, where you folks that are trying to actually, how can we rethink parts of these abstractions, and how can we slim them down without losing why these abstractions were created in the first place? And Steve, one of the reasons I think Rust is so successful is because Rust managed to dial this up really, really well, where there is a reverence for past systems while still wanting to improve the state of the art. And
Yes,
I don't.
that is like all Graydon, like maybe not all is the wrong way to put it, but like that's such a Graydon thing. I think that is great that Rust like inherited that. Sorry, I feel like I cut you off in the middle then.
No, you didn't come. No, I think it's great because I think that's really important in terms of like, and if that reflects like Graydon's disposition, that's a. I mean, that
like
is
Graydon.
really,
Graydon
really
is the
important.
person that knows the most out of programming languages that I know, like personally. Like you can mention the most hipster, obscure, offhand programming language to Graydon, and like not only is he like heard about it, he like knows the person who wrote the paper or like implemented it for fun, or like he just knows so much about the history of programming languages, and I think that's a large part of like why Rust fits together really well.
Well, because it feels like Rust considered for any given thing, it like looked across all languages and took the one that was the best, or the one that was. And there are, I mean, and just there were so many examples across the board where you kind of came up to like this. Wow, this is great. It reminds me of the RISC-V, same thing for kind of instruction sets. I love the mechanics of the RISC-V instruction set are great because they know instruction sets really well, and they looked around at like, what does x86 do well? What does ARM do well? What did Spark do well? What did MIPS do well? What did Power do well? And let's kind of take the best of all of that.
You're asking a long time ago about like where's Rust turn the corner or something, like as a like where's this go or like whatever. Also is kind of where you're just getting into. Linear in the chat linked a paper that also I think today is just like a wild thing to me personally, which is Consumer Reports has now put out like this report that's like, we need to get companies to care about memory safety. And they like directly say like that they have identified Microsoft and Apple as companies that they hope will get on board with the idea of voluntarily providing a memory safety roadmap and explain how they plan to eliminate memory unsafe code in their products over time.
Steve,
which
if
is like,
you have a deep mole operating at Consumer Reports, do you not need to confirm or deny this? But if you have a deep
blink
mole
once for
operating,
yes or blink two for no. Yeah.
Unsafe at NEC. Get it?
This is like, oh my God, the Rust Evangelism Strike Force has. This is amazing. This Consumer Report thing is.
It is amazing. I think that I wrote jokingly. I wrote. I can't wait to hear the conspiracy theories about this one to someone on Twitter about this earlier. But I think if you look at the names on it, it looks like maybe it's the ISRG getting in there. I would expect that's how this happened. But I would be interested to know like the story about why Consumer Reports is caring about memory safety. It sounds great, but I'm just like, this is just so interesting to me.
This thing is outstanding. It's well written too. Oh my God, I love the fact that they are calling us back not just to unsafe at any speed and Ralph Nader, but then going back to the jungle.
Yes, I know. I also it's like there are two works that like people associate with like unsafe manufacturing, and I was like unsafe at any speed. Okay, and like the jungle, and I was like, wow, are you saying C++ is like I found like crap in my food? Like is that the analogy that's being made here? Like
exactly, C++ is like the Triangle Shirtwaist Company. I mean, this is just. I mean, it is remarkable, actually, and great. I mean, good on them. And for that level of awareness, Linear Cannon, I'm not sure where you found this, but this is terrific. This thing is absolutely golden. Oh my gosh.
Yeah. So now that like as normie of an organization as Consumer Reports like cares about programming languages, like this is Rust turning the corner, basically, like IMHO.
Yeah, I think that's kind of interesting because I do feel that it's, and like this it was an NSA report that Strostrup was reacting to. I don't know what the report was that he was initially reacting to.
I forget if it was NSA, but I think it was the NSA. Yeah.
Yeah, but the fact that there's kind of this
NSA, you're on the call already. Please answer. Was it you or was it someone else?
Right. That's right. NSA, could you please give me audio problems right now if we are correct?
Yeah.
But the the fact that you're getting kind of these strident reactions to it, I think shows that like, okay, yeah, this is, we are getting a much broader awareness, and which is terrific. I mean, it is great for software, honestly, because I think it's so easy to kind of fall into the trap of like, oh, everything gets worse and it's bad, but it's like, actually some things can get better, and this is awareness of this issue, and boy, this is some really focusing it and sharpening it with this consumer reports thing is pretty great. And then I feel that like just to kind of bring it home for a second, then we'll kind of wrap it up to let Adam get back to his family. But I think that like that's the kind of problem statement that is really missing from Unikernels. Is like, and I think that it would be, I think, wise to, when we are going to change the abstraction, and if we want to get rid of something like memory protection, which again, I feel pretty strongly that we should have memory protection in the system, and I think it's a mistake to get rid of it. And I think if you're going to get rid of it, you need to get rid of it for really, really, really crisp reasons. But if you're going to get rid of a memory protection, then you need to have not just a great reason for doing that, but go build a system that way and learn when you're doing this. And then you can really show us, instead of just telling us, show us the systems that have actually been built. And it is, I think, less of a kind of an emotional appeal of like, look, we can get rid of all this crap and have nothing, and much more of a, hey, these are the actual benefits that this thing gives you.
Yeah. I was trying to look, and obviously this is during the call or whatever, but I was like trying to Google for like example of using Mirage OS, and it's like, here's your hello world, and I was like, cool, what about anything more significant than that? And it's like nothing. Like I can't find it. And I'm sure that exists or whatever, but the fact that there isn't like a clear immediate, when I Google like what's the biggest thing that uses Mirage OS, it should be like this thing, like super clearly, right? Like if you Google like what is Rust used for, it will like give you specific things.
Yes.
So yeah, I would agree that would definitely be, and that's kind of like why I'm like not, while I was like super into them in theory, why in practice does not happen in practice. It's just because like I'm not building that system, and I don't even know off the top of my head what that system would be for this. So it kind of, yeah.
And I think we've been able to kind of get to some other aspects that make that appealing in a vehicle that I think is very robust in terms of hubris, which is definitely exciting. So Johan, you got some nice closing questions. So you want to ask those? If I think I need, hold on. Steve, can you make him speaker? Because I think Adam has stepped away.
Yes, Adam did step away. I think I can do that.
I can do that, maybe.
Invite
There we go.
to speak. I clicked A.
All right. Johan, you want to close it out for us? If you're here.
Yeah, if you can hear us, Johan, the green circle's not appearing, so that means Discord is not picking up your audio. If you're saying anything. Still no circle.
God, this report is delicious. I want to do an out loud reading of this thing. Steve, I think you should do an audiobook of this. I think Audible. I think you should do the report, Future of Memories. Steve Klabnik reads.
That actually is very
report
funny.
On memory safety. I think it'd be terrific. All right, Johan, you there? A dramatic reading. Oh God,
sounds
so
like Discord problems, sadly.
Oh well, I guess it's gonna. Of course, the grass did seem so green over here. Then actually, probably it's been so much better than Twitter Spaces. I love having the chat, especially now that I can actually be in the chat. So, Steve, are you? Oh, no, you use your actual computer, your mic.
I'm on my desktop for both. Yeah.
So you're able to, that's how you're able to.
I do sometimes, like I can be on my phone and also like comment at the same time. Sometimes I will do that if it's like easier for some reason. Usually not, and for the purposes of like this, but like I don't know, occasionally, like at least it works. So
I
one
think
last thing about unikernels. I think my professors at Georgia Tech covered it pretty well. There were two classes that were co-rec that you had to take at the same time: compilers and operating systems. And the first lecture in the compiler class was, you don't really need an operating system. Operating systems are only there because our compilers aren't good enough, and you should compile everything down to what you actually want to happen so you don't waste machine resources interpreting things. And then you get to the operating system course, and they say, the only reason we need compilers is because our operating systems aren't good enough. You should just give them your code, and they build the code into something that's perfectly synced for that machine and gets the thing to run. And yeah, take these two courses simultaneously until they work to the end, and you realize that actually neither of those work at all. You're always going to have something in the middle, because no matter how much you think you're in runtime OS, web OS, all written in JavaScript, someone's going to ahead of time compile things so you get faster startups. And no matter how much you think you're in compiled time static world, someone's going to attach dtrace to your process and start rewriting it live. You're always going to be in a world where there's some kind of runtime that's messing with your stuff and some kind of compiler. So going all the way to unikernels doesn't make sense, and going all the way to a purely interpreted operating system doesn't make sense. We have to live in this world in between and say, okay, for this particular application, how much compilation do I need and how much runtime do I need?
So I'm actually desperate to ask you if this was pedagogically deliberate or this is a symptom of a civil war within the department. these two professors, did they actually like, you know what we should do? We should give diametrically opposed perspectives, force them to take both courses.
I believe that the two tenured professors decided to write their lectures together, each one saying that the other one was completely and utterly wrong about all things.
So it is coordinated at some level. I think we should coordinate on the fact that we hate one of those guys. I don't think we should it'll be great for the students. But that's, I mean, it sounds like you definitely, I came away with the right lesson. I think that this is an important, maybe a good place to close, a good thing to end on. I just think it's important that, you know, when we have these radical ideas, we want to kind of create these extremes. But the extremism can be thought provoking, but ultimately there's going to be a pragmatic middle. That is, there's always going to be a pragmatic middle, and that pragmatic middle is going to be the thing that we actually want to pay attention to. And so, because Johan's kind of closing question was, are we confident that unikernels can never be debuggable? I think it gets to Francois' earlier point. I guess I think that if you do not have that debuggability, I feel that sacrificing that debuggability makes it more difficult for the technology to succeed. I think that if for a technology to succeed, it's going to have to solve a real problem for someone. And I think that just there's too much ultimately that was not really solved, and too many problems that were created. And ultimately, and Dan is saying the pragmatic middle ground is unikernels with virtual memory and a debugging thread, which is, there we go, exactly, a general purpose operating system we're getting. And I don't think general purpose operating system. All right, well, I know Adam had said, boy, Steve, thank you very much for, and I mean, everyone, thanks for offering your perspectives on this. This is a kind of an evergreen debate. I imagine we'll come back here in 7 years and we'll pick it up then. But in the meantime, Steve, it would be, I think there was a suggestion in the chat, this report on the future of memory safety. We've got to get the authors in here if they'd be willing to talk with us and get.
Yeah, that'd be cool.
That'd be really neat, because this is a really interesting report and really taking on a very important issue. All right. Thanks, everyone. We'll talk to you next time.
Bye.